students, this is lesson 9.2 and it is called Solving Quadratic Equations by Graphing. Make sure that you label your notes really clearly, highlight the title, copy it down, label it, make sure it's very clear. Lesson 9.2, Solving Quadratic Equations by Graphing. Today we have a key concept that's really summarized easily with 3 little graphs. When we are looking at quadratic equations, we're going to see one of 3 situations. In the first situation here, I'll call this 1. In the first situation, we're going to see our parabola cut across the x-axis, this is x-axis, twice in 2 places, 1, 2. And when it does that, and we're trying to solve it, we are going to see that there are 2 solutions. In the second situation here, we will see that it just is going to come down and actually just touch the x-axis in 1 point. And in that case, we are only going to have 1 solution. And in the third situation, we're going to see our parabola floating in the air, either that or potentially down below, looking a little like that. Whoa, hang on, let me get that. There we go. Oh, that's good. All right. Down below like that, but neither of these cross. There's no crossing here, and so there's going to be no real solutions. So we're looking for one of these 3 situations today. Let's look at example 1. Example 1 says solve this equation by graphing. And again, you can follow along in your textbook, especially if you're home and you have your textbook with you. I'm on page 555. So I have an equation, x squared minus 2x minus 8, and the instructions say solve by graphing. So in order to solve by graphing, I'm going to pull up actually Desmos here. It's a nice graphing calculator. You can use a TI, and when you're doing your ALEKS problems, if they want you to have a graphing calculator, they will just give you one, and you can just enter your equations in that. So this is this first equation, x squared minus 2x minus 8, and I'm looking at this, and it is clear that I am going to cross the x-axis here and here in 2 places, so I know I'm going to have 2 solutions. I can tap on that actually in Desmos, and it tells me that this first one is at -2 and 0, and the second one is at 4 and 0. So I'm actually going to have 2 solutions, -2 and 4. So my solutions are x equals -2 and x equals 4. I want to show you something else just to make some connections. If I were to factor this problem, I would look at this -8, and I would want factors of -8, 1 and 8, 2 and 4. I need a positive and a negative when I multiply to make a negative, and when I add, I want this to be -2, and so I'm going to make my bigger numbers negative. And I know that 2 here and -4 actually makes -8. So factoring this, I would get x plus 2 times x minus 4 equals 0. These numbers should look a bit familiar and a bit strange at the same time, right? When I solve for the zeros using factoring, I make each of my factors equal to 0. And I'm going to just solve these little equations. Aha. I hope you're kind of seeing a bit of an aha. I get x equals -2 and x equals 4, which is the same thing that I got when I graphed it. That's because when we solve for these factors, we're solving for the roots. In fact, let's just write that. Sometimes we say answers. That's a very informal thing. Sometimes we say solutions. Sometimes we say zeros, because it's where y equals 0. Sometimes we say x-intercepts, and sometimes we say roots, and these all mean the same thing. We are looking for where does our graph cross the x-axis. So we can see this also when we factor. I wanted you to see this little opposite thing that happens when my factor is x plus 2. Then what actually happens is my solution is x equals -2. When my factor is x minus 4, then my solution actually ends up being x equals 4. This will help you when you do some translating on the graph and some other things to just see this relationship. All right, let's do example 2. Example 2 says x squared minus 6x equals -9. And I always want to solve these. Excuse me, the instructions say solve by graphing, but I always want to solve these for 0. I want them to equal 0 before I do anything because I'm looking for where y equals 0. Keep wrestling with these ideas and trying to make connections. All right, so I could factor this, but I am solving by graphing, and so I'm going to go look at the graph right here. We'll take that one away, and we'll add this one right now. And we can see in this graph that we only touch the graph in one place. It just comes down and lightly kisses the x-axis and then goes back up. So let's just touch this here. Let Desmos tell us that that's at 3 and 0, nice and neat. And let's go back to our problem. So we know that if it touches at 3 and 0, then x equals 3 is our solution. Now, if you were watching, if you wanted to factor this, you could do it the way we did the last one, but this happens to be a perfect square. X squared and 9 are perfect squares, and -3 and -3 make -6, and so this one happens to be a perfect square that looks like this. I only have to solve one of these because they're exactly the same, and I get x equals 3, the same as I got off the graph. So we call this a double root. When it only touches the x-axis in one place, we will still have these two factors identically the same. It's called a double root. All right, let's go to example 3. Example 3 has 2x squared minus 3x plus 5 equals 0, and it says solve by graphing. So I'm going to pop over to my graph and turn this one off and turn this one on. I'm not sure what's happening here. Turn that off, turn that on. There we go. And look what's happening. We are floating up in the air. Notice that we never do come down here and touch the x-axis. We are just floating up there, smiling in the air just like the Cheshire Cat. So we will say in this case that there are no solutions. If I try to factor this, I will not find factors that work because factoring is leading me to those roots where it crosses the x-axis. And there are no nice factors for this. There is a topic called imaginary numbers, and that's buried in Algebra 2. It's very fun, but is not in the scope of Algebra 1, so you'll get to that later. All right, I'm going to stop there, keep this short and to the point, and let you do your work. And Alex, please let me know what your questions are. Please send me topics. Please come see me or arrange a time to come see me, ask in class. Please be dialoguing with me. You are not supposed to sit and in despair, not understanding. So please come and get some help.